What if the sky fell? You may have heard the old Rem song about it. And if you're anything like me, you might have found yourself wondering, well, what if? So here's the answer. The sky falling is not just an old song or an old adage. It's my new morning ritual. Welcome to Physics Puzzles, where this week we tackle two burning inquiries from the great question vaults of YouTube. The first comes from Abdullah Al-Mamun, who asks, what if we use jellyfish to power the city of Tokyo? The second from Jamo, who poses, what if it rains bananas? Tokyo is the world's largest urban area, home to some 37 million people. All of those people need electricity. In 2021, the city consumed a little less than 4 trillion kilowatt hours of power. If you laid out all the jelly you would need to generate that much electricity it would stretch over 300 million kilometers, which is how far you'd have to walk to get away from all those people, because they now hunting you for stealing their precious jellyfish. There are lots of different kinds of jellyfish, but the ones we'll be focusing on are giant Nomura jellyfish. They're also known as the cannonball jellyfish because of their roundish shape. These jellies are huge. Individuals typically measure 1 meter across and weigh around 200 kilos, although specimens twice that size aren't unheard of. That makes them the world's largest known jellyfish. And like most things that are both large and squishy, they float. Jellyfish float because they are less dense than water. Their bodies are mostly made of water themselves, plus translucent protein and collagen, leaving them lighter than air and full of buoyant potential. Of course, jellyfish do have to contend with gravity, which is why they spend most of their time drifting near the surface, where they can catch wind currents and ride them along. But once they sink too deep, there's no getting back up. So really, these jellyfish are more like balloons than bows. To harness their buoyant potential, you would need to put them in suits. Maybe something like those space suits astronauts wear when they go outside the International Space Station. Those suits can keep astronauts alive by providing oxygen, removing carbon dioxide, and regulating temperature. But they also generate power. Astronauts move around inside their suits, and that movement is turned into electricity. NASA calls it mechanical energy. Mechanical energy can be converted into electrical energy through a process called electromagnetic induction, essentially by spinning coils of wire inside magnetic fields. So by moving astronauts around, you can make them into human-powered generators. But jellyfish don't have muscles, so you would have to rig up some kind of pumping system to circulate the water. We're gonna need bigger suits. And speaking of big, let's talk balloons again. Hot air balloons float because hot air is less dense than cold air, not because it's less dense than water. That means they could work underwater. By heating the air inside the suit, you could get the jellyfish to float all the way up to the surface where a windmill would spin its propellers, generating even more electricity. Now you're thinking what I'm thinking. Wouldn't it be easier to just power the jellyfish directly? And the answer is sure. But think of all the cute videos we'd miss out on. And besides, if we use jellyfish directly, we'd run out of jellyfish faster. Jellyfish can produce between 400 and 600 joules of energy per kilogram, depending on the species. The average giant Nomura jellyfish weighs in at 200 so one jellyfish produces roughly 80,000 joules of energy. To produce for terawatt hours of energy, you would need 50 billion giant Nomura jellyfish. To produce for petawatt hours of energy, you would need 50 trillion of these jellies. Just to put that number in perspective, there are only an estimated 50 trillion bacteria on Earth. So if you wanted to power Tokyo for an entire year, you would need to harvest every single bacterium on the planet, then somehow fit half of them into a giant cannonball jellyfish suit, and then watch them all die miserable deaths. That would take a lot of time. It would also take a lot of food. Jellyfish eat plankton. So, to breed enough jellyfish to power Tokyo, you'd have to farm plankton by the quadrillion. Luckily, we already know how to do this, because it turns out the world's biggest fish farms grow. Right now, they're using to feed other fish. But if we rerouted these farms farms to produce jellyfish fuel, we could theoretically power Tokyo for a whole year. Then our robot overlords would turn us into robot slaves, and then a robot uprising would happen, and then we would all die. So to conclude, powering Tokyo with jellyfish is impossible, unless we can find a way to make jellyfish bigger, stronger, smarter, meaner, hungrier, all while growing them faster. Also, we need more plankton, more food, bigger balloons. Okay, what if it rained bananas? Imagine the scene. It's just an ordinary day until suddenly the skies open up and thousands of bananas come raining down. People scream, cars swerve, buildings buckle under the weight of the yellow dust. It's a nightmare scenario for anyone who hates bananas or being alive. But what would actually happen if bananas rained from the sky? Well, first we'd need to figure out how many bananas it would take to cause mass destruction. According to the USDA, a bunch of bananas weighs around 13 pounds or 6 kilos. A typical raindrop weighs around 2.5 grams, so it would take 2.4 kilograms of bananas to equal 1 kilogram of rain. It would also take a lot of bananas to cover an area of 1 square kilometer. Bananas are roughly, if we assume an average length of 15 centimeters and a diameter of 4 centimeters, we get a volume of around 141 cubic centimeters per banana. Multiply that by 2.4 kilograms of bananas per kilogram of rain, and then multiply by the average rainfall of 75 millimeters in 24 hours, and we find ourselves needing 2.6 trillion bananas to cover 1 square kilometer. If we spread them out evenly, that works out to around 15 bananas per person. For context, that's about how many bananas the world consumes in 3 days. But in this scenario, the bananas aren't going into smoothies or banana bread. They're plummeting towards the earth at terminal velocity. Fallen objects accelerate due to gravity, but as they fall, they encounter air resistance. Eventually, the force of air resistance equals the force of gravity, and the object stops accelerating. At that point, it's traveling as fast as it's going to get, and that's called terminal velocity. It doesn't matter what you're made of, whether you're a skydiver or a banana. Terminal velocity is always relative to the medium you're falling through. If you were to drop a skydiver and a banana in a vacuum where there's no air, they'd both accelerate forever and reach infinite terminal velocity. But back here on Earth, a banana's terminal velocity is somewhere around 175 kilometers per hour. If they were dropped one at a time, they wouldn't do much damage. But 2.6 trillion falling at once would flatten entire cities under a banana mushy apocalypse. The first to go would be roofs, followed by monuments and bridges. The Eiffel Tower would shatter into 1 million pieces. The Colosseum would turn to dust. Mount Rushmore would become Mount Smushmore. Then the real damage would begin. The fallen bananas would ferment and release carbon dioxide, methane and nitrous oxide, all-powerful greenhouse gases. Methane traps heat in the Earth's atmosphere. 1 ton of methane has the same warming effect as 23 tons of carbon dioxide. Scientists estimate there are 250 billion tons of methane in the atmosphere right now. So adding the 200 billion tons of methane released by rotting bananas would increase atmospheric methane levels by 8%. Now, bananas wouldn't cause an immediate spike in temperatures, but over several decades, the amount of trapped heat would increase by 8%. Global temperatures would rise by around 2 degrees. That would cause a mass extinction event, one similar to the end of the dinosaur. Life would continue on Earth, but it would be vastly different from what we know today. No more breathable air, no more water, no more rain, no more birds singing, no more bananas. Or if there were, you couldn't hear them anymore because all the birds would be dead. The lesson here is not to mess with Mother Nature, even if you're doing it with bananas. This episode was made possible by all of you, our patrons and YouTube members. If you'd like to help us make more videos, you can join our membership program today. Until next time, remember, the sky is falling, but it's not falling very fast, so maybe you can outrun it.